Calculus Kids, this is Dr. Callahan with Week 3 Friday. Go ahead and pause the video and answer the following 3 questions for your warm-up log. Let's go ahead and create the assignment for today. And this is going to be Week 3 Friday, and it's AP Calc AB Semester 2. And today we're going to talk about U substitution for integration, day 2. The instructions today is to simply watch the video, view the assignment, upload your work. Keep in mind that it is equivalent to 50 minutes of instructions. And the 2 links that you need today is going to be the following 2, one for the Google Doc, one for your YouTube channel for the AP Calculus. And of course, you have hard copies that if you need, you can always pick up outside my door. And then again, this is your class schedule. So for you guys, you're in 2nd period. So make sure you're logging on at 8:46 and then ending class at 9:41 because it should be equal to 55 minutes of instruction. And of course, you guys get the 10 points for attendance, and it's always due by 3 p.m. the following day. So let's go ahead and sign this. Okay, so looking at today as to what we're going to be doing with your guided notes, and I'm going to go ahead and attach it to MS Team as well. The big one that you need is this one right here. Excuse me. So we're going to go over, I don't know if I have time for 8 examples, but we'll certainly go over as many as we can for this class today. And it's our 2nd day with integration by substitution. And that is your guided notes. So if you go ahead and click on it, you'll be able to see it. I also have a 2nd one here as well that I am going to attach. And these are the questions from your textbook problems. So make sure you go over them. There is a link on the very top that actually have the videos that accompanies the problem itself. So there you go. You have 2 different ones right here. All right, so with that said, let's go ahead and get started with today's step then. So this is your warm-up right here. This is one of the questions that we actually talked about yesterday. That was part of your guided notes, but I figured today we'll go over this as a warm-up as well. So yesterday we talked about U substitution. So finding which one to use as a U substitution to let U be is kind of a craft in itself. You want to kind of identify where the chain rule is going to happen. And if you look at this right here, you know another way of writing this is sine 3x squared. That 2 just goes up there. So generally, the chain usually happens inside the square root or inside the parentheses. So I'm just going to let U be sine 3x. And then du, which is the same thing as u prime, where the derivative of u, is going to be a cosine 3x times the chain of 3x, which is 3 dx. And a lot of times you have to solve for the dx. So dx is going to be du over 3 cosine 3x. All right, now let's go ahead and replace this with u. Integral u, don't forget your squared cosine 3x dx. Okay, now let's go ahead and take a look at this. Integration of u is going to be 3 divided by 3 integration of u cubed over 3 times cosine, or actually, you know what? I totally jumped the gun on this. You can't do the integration of this until you have one consistent variable. And in this situation, I have a x, but I need this in terms of u. So let's go ahead and replace a dx with what I have here. So integral u cubed over 3 cosine 3x times, replacing the dx with whatever this is equal to, which is a du over 3 cosine 3x. And lucky for you, you can cancel the 3x or cosine 3x. So then you have a 1 over 9, which you're going to put over to the left side. So I'm going to have integral 1 over 9 on the left, u cubed. I need to get rid of this 3. It's not quite there yet. Sorry about that. Or no, it is there. Just kidding. Over 3. Wait, is it over 3? No, it is. Yes, it is. It is. Sorry. I'm like, I'm not sure now. Oh, hold on a second. Let me see. No, it's not. It's not there. Sorry. I integrated before. I apologize. So actually, it's going to be 1 over 3. There you go. Sorry about that. And then you're going to go ahead and integrate this because this is in terms of du. So 3 plus 1 equals, it's a 2. Oh my gosh, I'm so screwing up. I apologize. It's a 2. Sorry. Plus 1 equals 3 divided by 3, which is going to be 1 over 3 times 1 over 3, which is 1 over 9. U, so I'm going to replace the u as sine 3x to the third power plus c. Wow, that was really bad. Sorry about that, guys. Got a little bit ahead of myself, but that is your answer. All right, so let's go ahead and continue practicing this today. So for today's stuff, your breakdown looks like this. It's a continuation of u substitution. And I'm going to go over some examples with you guys in class. Take a look at your guided notes. So this is going to be your notes in class. There are 8 examples. I have my steps right here written for you guys. This right here kind of tells you the meaning behind why we use u substitution. And then this is from your textbook. The link is up here, so you're welcome to go ahead and watch the video and practice with some of this in your textbook. All right, so then with that said, let's go ahead and just jump right into the notes for today, which is right here. Okay, so looking at this right here, go ahead and read this. And I kind of want to briefly add a little notation here. What's happening? Onto the slide as to why we use u substitution. So the reason why we use substitution is you can think of it as, I'm just gonna put like a little star, u sub is a method of rewriting an integral problem into a simpler one to help us identify an integral rule that is appropriate for the problem. Okay. In a way, it's kind of reverse of the chain rule. So you could think of it as that way, because you can't really integrate the chain rule. So a lot of times that becomes somewhat problematic. And let me just change that. There we go. And make that red. And hand it over. Cool, cool. All right, so let's go back to this then. There we go. Okay, so those are the steps. There are 7 steps for this. And let's go ahead and get started with it. All right, so you should have read example 1. It was pretty self-explanatory, has all the steps and the components necessary for it. Now let's take a look at step number 2. Okay, for step number 2, you could, I wouldn't suggest it, but yes, technically you could go ahead and change this entire thing. So that way, instead of having a parenthesis, you have a polynomial, which would require you to go ahead and multiply this literally to the 15th power, which I don't think you really want to do that 15 times, and then distribute the x, and then integrate separately using the power rule, the reverse power rule. Or you can go ahead and use the substitution. So in this case, where do you think the change is happening? Most of the change is happening inside the parenthesis. So let's let u be x squared plus 1. du is going to be 2x dx, and then dx equals du over 2x. Once I have that, let's go ahead and substitute. So I have x times u to the 15th power dx. Now I need to have one term, which is going to be u. So I'm going to go ahead and replace the dx with that part right there, du over 2x. Which is great because what ends up happening is that this x and the denominator x cancels. My 2, or 1/2, goes on the outside of this. And now it's everything in terms of u, so I can now go ahead and proceed forward to integrate it, which gives me a 16. So I'm going to divide it by 16, which is going to equal to 1 over 12, or excuse me, 1 over 2, times the 16, which is going to get 1 over 32. U to the 16th power plus c. And of course, if I substitute everything back, u originally was x squared plus 1 to the 16th power plus c. And that is going to be your answer. All right, let's go ahead and take a look at example 3. So once again, looking at example 3, what would you like u to be? You could try u being x squared, but you're going to find out soon enough that you're never going to be able to make this entire problem in terms of u, just simply in terms of u. So you're going to get stuck because you're never going to be able to get rid of the x's. So it's kind of like an art in a way of doing this. Remember, the chain rule is always happening inside the parenthesis. So in this case, let's let u be 2x cubed. So then your derivative of u is going to be 6x squared dx. And your dx is going to equal to du over 6x squared. Perfect. So then let's go ahead and substitute everything in. Replacing the 2x cubed with a u, dx. Okay, well, not everything here is in terms of u, and that's exactly what I want. So I'm going to go ahead and go back, and let's go ahead and replace the dx with a du over 6x squared. From here, I know my x squared on top and the x squared on the bottom can cancel. My 1 over 6 can be moved over to the left side, and I have secant squared u du. And as you guys know, that the derivative, or excuse me, the integral of secant squared u is going to be tangent u. So the integral of secant squared u equals tangent u. It's one of the formulas that you would just have to memorize. And so this will be 1 over 6 tangent u plus c. Last step, replace a tangent u with the original substitution plus c. How are you guys feeling about this? I hope this is okay. All right, let's go ahead and move on to the next question. Let's go on to example 4. Now with example 4, if you take a look at this here, you have a square root, which we don't really like, but that happens sometimes. So what would you let u be? And remember, your chain rule oftentimes is also inside the square root. So your integral, or excuse me, you're gonna say let. And actually I wanna put that as a disclaimer. So that way I have this for next semester. Oh shoot, that just totally messed it up. In slideshow, let's see, discard. Okay, so let's try this one more time. Okay, so with this one, I'm just gonna go ahead and insert. And I'm just gonna put a disclaimer. Most of chain rule occurs in parentheses or square roots. Hence, let u equals whatever is in parentheses or square root. All right, so let's go ahead and give that a try. So in this situation, we're probably gonna let u equals inside the square root 5 minus x to the fourth. Du is going to be negative 4x to the third dx. Dx is going to equal to du divided by negative 4x to the third. And already, you guys, you should probably kind of like glance a little bit in the future and go, okay, my goal is ultimately to get rid of that. And guess what? I have it right there. So that makes me a happy girl because I know that I'm not going to run into issues when I'm integrating this. So I have x cubed square root of u. Replace your dx and replace it with a du over negative 4x cubed. And I can go ahead and cancel that cube, so that's gone. Move the negative 1 over 4 outside of the integration. Replace the u to the square root to 1/2 du. Everything is in terms of u, so all in terms of u. So yay, now you can proceed forward. So when I go ahead and integrate this, we are going to do a +1, so it's a 2 over 2. That's a 3 over 2. You gotta flip that, so that's gonna be a 2/3 u to the 3 over 2 plus c. That gives me a 1 over 2, negative 1 over 6. Replace your u with a 5 minus x to the fourth, 3 over 2 plus c. And that is your answer. Now, if you want to check your answer, what you can do is you can find the derivative of your answer, which then should equal the original question. And if it does equal that, then you know your answer is correct. Because remember, the opposite, or excuse me, the derivative of the answer of the integral is equal to the problem of the integral. All right, let's take a look at number 5. Okay, so for this one, you have a tangent 5x, so that's like a tangent x to the 5, and then you also have a secant x squared. So this one, I mean, honestly, I seriously don't actually know which one I'm going to be able to use to let u be. You can think about the fact that, well, if you think ahead, if I let u be tangent x, what is the derivative of tangent x? If I'm thinking ahead, I know that derivative tangent is going to be secant square x dx. That's good because these two are exactly the same. my goal is to get rid of the secant squared x because it's still in terms of x. So I also know that if I were to solve for dx, I will have the secant squared x underneath in the denominator, which is exactly what I need to cancel that secant squared x. You can also try and say, okay, let u be secant x. Okay, well, what is the derivative of secant x? Well, the derivative of secant x is going to be secant x tangent x. Okay, well, then you know dx. Dx is going to equal to du over secant x tangent x. But then that's going to be a problem because how are you going to cancel tangent x to the fifth when you don't have enough over here? So as you think ahead of this, you're going to be like, okay, so this one probably not a good one to use to let you be secant x. So this one here will be the winning one. So you might want to think ahead about that so that way you're not wasting a lot of time. So now that I have this, I'm going to have my integral u to the fifth power secant squared x, replace your dx with a du over secant squared x. And then what you can see here is that this and d cancels. So you have the integral u to the fifth du. So 5 plus 1 is a 6 divided by 6. So I have 1 over 6 u to the 6 plus c. And if you go ahead and replace the u with a tangent x, the 6 plus c, your answer is just tangent to the 6x plus c. And that's your answer. Okay, so let's take a look at example 6. Trying to use u substitution is not always in your favor because if you could actually avoid using it, all the better. If you could use the reverse of the power rule, that would be great. But sometimes, like, in certain situations, examples 1 to 5, you're not able to. Take a look at example 6 and ask yourself, is there any way that I can maybe avoid using u sub? And in this situation, I mean, you might want to pause the video, kind of try to manipulate the equation. The way I kind of see it is I see that there is a 1 over square root of y. I know that that's y to the 1/2, and if I bring it up, it's going to be y to the negative 1/2. Well, there's nothing that says I cannot distribute that, so I'm going to go ahead, of course, distribute it. So 3y to the negative 1/2 minus the integral of y. Remember, this y is a 1, so it's a 2 over 2, times 1 to the negative 1 over 2. You're going to have to add that, which will be y to the positive 1/2. And then we have like this way, you can just proceed forward with the integration, which will be pretty easy, so you don't have to use u sub in this situation. All right, let's go ahead and take a look at example 7. Example 7 looks like a fairly simple equation, but in this situation, it might be a little bit complicated, and I'll show you why. So once again, you want to use the u to be inside the square root. Du is just actually a 1 dx. So dx equals du. Okay, perfect. So then let's go ahead and rewrite that. If I rewrite this as an integral of x u to the 1/2 dx. Immediately, I know I can replace a dx, but the problem here is there's nothing I can cancel to get rid of the x. So I'm a little bit stuck here. So in which case, is there another way for me to go ahead and rewrite this x in terms of u? Let's go back to the original u equation. Is it possible for me to take that equation and go ahead and solve for x? So hopefully I have something that will equal a u. I will have to subtract the 3, so x equals u minus 3. So let's do that. I'm going to take this, replace it here. So I have the integral of u minus 3, u to the 1/2 du. Everything's in terms of u, and guess what? This is just like the last former example, but you're going to have to distribute it, okay? So you have u2/2 times u to the 1/2. That's going to give you a u to the 3/2 minus 3u to the 1/2 du. And you would just have to go ahead and integrate this separately. So plus 1, which is 2/2, is a 5/2. Make sure you flip that, which is a 2/5 u to the 5/2 minus, and then of course you have the plus 2/2, which is a 1. That gives you a 3/2 divided by 3/2. So you have a 3 times, flip this, 2/3 u to the 3/2 plus c. Replace the u, 2/5 x plus 3 to the 5/2 minus 2 x plus 3 to the 3/2 plus c. And that is your answer. Okay, you know what? We have enough time. I'm just going to go for it. Let's go over example 8. And I'm actually going to move this one up a little bit so that it's a little bit easier for you guys to see. So here's my example 8. Whoa, no, that's not what I want. Okay, for some reason it's just not letting me move this, which is semi-frustrating. Hold on a second. I can just insert a new slide. There we go, and then paste it over here. Okay, ta-da, that should work. There we go. All right, so let's take a look at this one here. Oh, for crying out loud, stop it. All right, so looking at this here, what would you let your x be? Or I'm sorry, what would you let your u be? Traditionally, we'll just let u be 2 minus x. Then du will be a -1 du, okay? So u equals, oops, I'm sorry, dx, not du, dx. So then dx equals a negative du. All right, so far so good. So let's go ahead and rewrite this. If I rewrite this, I have x squared times u to the 1/2, replace that dx, it's going to give me a negative du. Uh-oh. So far, nothing is going to change that to get rid of the x squared. So we're kind of stuck here for a little bit. So once again, if you're stuck on this one, you want to go back to the u substitution, which is right here. And then what you want to do is you want to solve for x in terms of u. So I'm going to try to solve for x in terms of u. So that'll give me a negative x is equal to u minus 2, positive x equals a 2 minus u. All right, so then let's go ahead and replace this over here, which will give me an integral of 2 minus u squared times u to the 1/2 negative du. Okay, you guessed that. You probably will have to FOIL this. Okay, if you FOIL it, you will get the integral of 4 minus 4u plus u squared times u to the 1/2 times negative du. You will have to distribute this into all three. So you have the integral of 4u to the 1/2 minus 4u, 2 over 2 plus 1 over 2 is 3 over 2, plus u, this is going to be u squared times u to the 1/2. You need to have a common denominator 2, which is a 4. That's u to the 5 over 2 times negative du. And guess what? Everything's in terms of u. Now, I don't like that negative here, so I'm just going to move it out to the front. Okay, so at this point, you can go ahead and find the integral of this, plus 2 over 2, which is a 3 over 2, divided by 3 over 2, flip it, which is a 2/3 u to the 3 over 2. Next one, let's go ahead and take a look at this one here. You're going to add a 2 over 2, which is a 5 over 2, divided by 5 over 2, flip that, which is a minus 2 over 5 times 4 u to the 5 over 2. Last one, plus 2 over 2, which is 7 over 2, divide the 7 over 2, flip that, which is a 2 over 7, u to the 7 over 2, plus c. There we go. And of course, your last step is to go ahead and distribute that negative, replace the u back into its original equation. So negative 2/3, 2 minus x to the 3 over 2 minus 2/5, or actually 2 times 5, or 2 times 4 is going to give me an 8. 2 minus x to the 5 over 2 plus 2/7, 2 minus x to the 7 over 2 plus c. And that negative, that should be a 2/7 should be a negative because of this negative, and then minus c. Ooh, that was a long example. Okay. So now that we practice with all the QA questions, I will highly suggest that your next step is to go ahead and go to this page here. These are some of the questions from your textbook. If you're encountering any difficulties, make sure you guys type in that link to watch the video that goes over these questions from your textbook. All right, as always, stay safe and healthy, and I'll see you guys next time. Take care.